Thank you. Okay, so we're going to start with Class E airspace, and it goes only up to 17,989. And why is that? Does anybody know the answer? If you know the answer, raise your hand. Okay. Jacob. No. Osvaldo. That's correct, because 1 foot above that is Class A airspace. I would really suggest you guys review at least once during the week the notes that you're taking in this course, because at some point in time the notes are going to get more and more and more, and pretty soon, if you're not even bothering to go back and study or try to remember the major classes of airspace, there are only what? How many major classes of airspace are there? A, B, C, D, E, and what else? What happened to F? Foreign only, right? G. Okay. Okay. Here we go with our standard visibility. 3 statute miles, clear of the clouds, above 10,000. Did you note the visibility? Okay. I'd want 5 miles too if I had a Boeing 777 coming out of a cloud. That means in clear air, with no clouds to interfere, you want to be able to see other aircraft that are traveling at high rates of speed. But people just somehow or other do dumb things. And I'll tell you a quick story. In the Owens Valley, there was a glider pilot who had borrowed a glider from a friend of his, and he was up at 16,500 feet, and he was flying in a circle because he was in a thermal. On board, he had what is called a transponder. A transponder is the device that answers when it is interrogated by a radar system somewhere. It could show up on radar systems in not only in Reno, but also in Bishop, and also in Minden, and also other places. For example, if you're on radar at FAT, like you saw, right? The same people who have a radar in Bakersfield and a radar up in Stockton can see you as well. And as well, Oakland Center, which is high altitude, they can still see you down low, right? So he had this transponder in his glider, and he didn't bother to turn it on. Along comes a corporate jet down the Owens Valley and hits him. Half the wing gets embedded in front of the corporate jet. The gal who was the captain got sprayed with glass, so her face was a shambles of cuts from the jet finally made it. The guy in the glider, after it got completely demolished in the air, he had a parachute on. He had a couple cuts and bruises. But the stupidity of having a glider at that altitude and not bothering to turn on the transponder is something that's hard to believe. So, yes, things like that happen. Jacob? Did he go to jail? Pardon? Did he go to jail? No. No, he didn't go to jail. Well, sometimes, laws against stupidity are there. Okay, so above Class E airspace is Class A. And it goes from 18,000 to 60,000. And just keep in mind, this is unbounded airspace. We're going to get the bounded airspace shortly. But I'm hoping that this will be a review for you, since we've gone over it a number of times in the past. We've had one long lecture on this subject. The lecture took all of the 2 hours from 1 to 3, or from 1:20 to 3 o'clock. Not quite 2 hours, an hour and 50 minutes. But so it's something that you have a note full of information on it, and now you're taking notes again, and that's good. Now you should be trying to key your memory of what you remembered from before. Okay, in Class A, there aren't any cloud clearance restrictions. Why not? Because everything is IFR. Instrument Flight Rules. So it doesn't make any difference whether it's a clear visibility sky and the commercial jet takes off out of LAX and is going to go to New York and there's not a cloud in the sky at all. He still has to file and fly an IFR flight plan. So everything above 18,000 feet is an IFR flight plan. Except, I'll tell you what the exception is. I don't want you to remember it because it's going to confuse your poor brains. So the exception is that in the Owens Valley and other places around the country, but mainly here in the western United States, we have what is called a wave window. Do you remember we talked about mountain waves? And that is the most fearsome source of lift ever. And that the world altitude record of 76,124 feet was set in the Andes Mountains in South America in a mountain wave. Okay, so in the Owens Valley, marked on a map, the copy of which is given to all the glider schools in the area, plus the FAA has a copy of the map, it shows the boundaries of what is called a wave window. So if it's a good day and the guys want to get up over 18,000 feet, they call the FAA and say, would you please open up the wave window? So the FAA, if they decide that it's okay to do it, it's clear enough, they will say, okay, the wave window will be open from noon to 8 o'clock tonight. That means that gliders can thermal or fly up above 18,000 feet and into Class A airspace, and they don't even have to have a transponder. Now, most of the gliders that I know that go up that high, up to 35 and 40,000 feet, have transponders. They want to be seen on radar. So it's not a matter, they're not required to have it, but so that's a situation where there's a minimum FAA standard, but pilots are not acceptable to them to have a minimum standard. They go much more than that by installing at their own expense a transponder and a glider so that they can be seen. So it's a situation where, yes, there are exceptions, but I don't even want you to remember. I just want you to keep in mind that there are some exceptions almost to everything in life, and that's one of them, where you can go up into Class A and not even have a transponder on board or an engine or anything else. Okay, so there are no visibility restrictions either. Now, they will not open the wave window if the weather is so bad that you can't see above 18,000 feet, because gliders are not allowed to fly in IFR or IMC, right? Isn't it the correct term is IMC? Right. Okay. Instrument Meteorological Conditions, IMC. Okay. All IFR flight. That's all you have to remember. And my guess is that there might not even be a question at all on anything above the top of Class E airspace. I doubt it right now. I don't think there will be. Somebody could say, well, wait a minute, I'm going to go to Pikes Peak in Colorado and I'm going to fly off the top of Pikes Peak and that's 14,000 or it's 12,000, whatever it is. Yes, but I forgot to tell you, Class G follows the curve of the Earth, doesn't it? So Class G airspace can be as high as 14,624 because Mount Whitney is 14,220, 14,200 something, and so you can be 1,200 feet above Mount Whitney and still be in Class G airspace. So Class G airspace follows the terrain. Okay, and above 60,000 feet, up to 320 feet, is Class E airspace, and then above that is outer space. So you don't have to worry about that. I told you before, those are just a couple little unique pieces of information that are never going to be tested. You're never going to be tested on it. It's just if anybody ever talks about it, pilot friends of yours, you can ask them the question, well, what's above Class A airspace? They won't know. they'll think, well, I don't know, it's probably outer space or something. Well, it's not outer space. It's Class E up to outer space. But don't worry about it. So here we go again, right? Now we're taking a look at the same thing we started off with, but in this case, I made those little boundaries, those little funny little things that look like restricted areas, and the round ones are airports. As you can tell, my artistic talents are not great. So here we go into bounded airspace. Part of your test in December is going to include what they call a supplemental little book. And in that little book called a supplement are going to be charts and aeronautical charts that have the same information on them that I'm going to show you today. All right? The most important thing that you can be aware of is that color on an aeronautical chart is a very, very important thing. And remember, I asked you one of the questions: what does yellow represent? Right, populated areas. So, color on an aeronautical chart is a major definition of what that color represents. All blue circles are airports with control towers. All magenta circles are airports without control towers. So the solid blue is more important than solid magenta. Solid magenta is more important than dashed blue. So you can see right off the bat that solid and dashed, solid is more important than dashed, blue is more important than magenta. And there are literally tens of thousands of symbols on all the aeronautical charts in the United States that have representations of blue and magenta and yellow for populated areas. So just keep in mind, solid and blue. And I'm going to show you examples because today we're going to drift into aeronautical charts because they're going to be an important part of your testing. So the real basic issue that you need to remember, not necessarily so much the open circles and the closed circles, but the thing you want to remember are the blue and the magenta, the dashed lines and the solid lines, and the blue circles and the magenta circles. The blue circles being probably more important because a blue circle represents an airport with an operating control tower. And a non-hard surface airport is one that's either dirt or grass. If it's even crumbly asphalt, it'll still be considered a hard surface airport. But if it's gravel or sand or dirt or grass, then it's considered a non-hard surface airport. And it'll be an open circle, not a filled-in circle. So the solid blue, the solid magenta, the dashed blue, and the dashed magenta go along with the classes of airports, A, B, C, and D. So that's pretty easy to remember. Somebody says, well, what about, B, C, D, and E? What about Class B? Well, Class B is so important that it must have a solid blue around it. And the answer is yes, it does. It has a solid blue around it. And I'm going to show you that in a couple of seconds here. Everybody ready? Okay. I'm glad to hear that you are conscientious enough to make sure you write it down, because when it comes time to study, which I hope you will between now and December, that you'll be able to get it. The faded in and the faded out, I will show you that. It's unlikely that there is going to be any major question on it. If I detect a question on lines that are faded in or faded out, I will bring that to your attention. But right now, I don't see any questions in the future that have anything to do with faded in or faded out. But I'll show you what it looks like. I'll show you what the faded in, faded out looks like. Ready? Okay, here we go again, right? Bounded airspace around a big airport like LAX and San Francisco and O'Hare Airport and John F. Kennedy in New York. Class B big jets. This should be very familiar territory to you. Remember the visibility. Yeah. Remember the visibility. 3 miles. Do you remember why that's the case? I'll show you in a minute why it's the case. Yeah, right, exactly. Traffic, for traffic purposes. Clear the clouds. All they want you to do is get around that cloud and get on the ground. And as I mentioned before, most major airports in Class Bravo airspace are located near major bodies of water, either quite large rivers or big lakes or oceans. Because that's how commerce developed in the early days. That's where the boat traffic came. And so that began to provide a business center for commerce. And as a result, since the barge and boat traffic was already there, they decided to locate the airport because that's usually where major cities develop. So airports are to serve major cities. Okay, here's that chart. Yes, sure. The chart I'm going to show you, I improved a little bit on. Through the last time, I kept looking at it and couldn't stand to see what I was looking at. So I decided to trash that. And I came up with a little bit better by using Google Earth. I used a picture from Google Earth, Los Angeles International Airport. And therefore, it should be a little bit better. So up on the right-hand side, you see Los Angeles International Airport over here. They have 2 sets of parallel runways. On the left are 2.5 and right. On the right are 2.4 and right and left. 2.4 right and left, 2.5 right and left. They all point in the same direction, but they could not possibly have called them all 2.4, 1, 2, 3, 4. So the ones on the north side of LAX are termed 2.4 left and right. And the ones over here are termed 2.5 left and right. Over here in this area is where the general aviation airplanes land and are serviced. There's where the FBOs are, the people who handle general aviation airplanes. All the rest in the center here and all the way out to the shore are all, it's either terminals or they're big hangars. So here we are coming along here. We're going to enter into and land at LAX. We're going to land on 2.4 right, which is this runway right here. And so we get here and we call the controller and he says, Roger, Dakota 250 or 50 uniform. Look to your right, you see the 747 3 miles away? Yes, I do. Look to your left, see the DC-10 3 miles away? Yes, I do. All right, you're going to follow the 747, you'll be in front of the DC-10. 3-mile visibility is you have to have it in order to be sequenced into LAX. Unless there are no other aircraft in line all the way back maybe to Ontario. And if that's the case, then he'll just say, you know, make right traffic for runway 24 right, which means that when you get to an angle here where you're now about lined up with the runway, you turn right and go right in and land. Okay? But most of the time, there's so much traffic going along here in this route to land here, and also to land over here, that coming from the north, you have to be able to see 3 miles. And the same in the south. If you're coming from the south, you're going to be getting in sequence with people landing on 2.5 left. And you can see of the 2 runways, this is 2.5 right, this is 2.5 left. There's a much darker, longer strip on 2.5 left. Does everybody see that? That runway right there has a tremendous amount of black on it compared to 2.5 right. All right? So why do you think that is? Well, they're both used, but the one on the left is used more often for landing, and that's where the tires get ripped up, where they leave a lot of rubber on the runway when they land. Because remember, a tire is sitting there doing nothing, right? Huge tires. I mean, they're gigantic tires. And they're just sitting there calm, and all of a sudden they hit concrete, that the concrete's going 140 knots. So you can imagine that that tire that's not rotating now has to immediately rotate at 140 knots. So that's the reason they leave so much rubber on the runway. Okay, so this is the reason why on Class Bravo airspace it's 3-mile visibility and clear of the clouds. And where the clouds are going to likely be is over here, nearing the end of the runway in this area, if there are any clouds at all. Not very often. You know, sometimes when there's a change of weather, LAX will have clouds there. So will San Francisco, more so, because they get a lot of fog in San Francisco and they don't have that much fog in LA. Okay? Everybody okay? Questions on this? All right, let's go. So, Los Angeles area airports, I'm going to go very quick. I'll show you. Way over here is Los Angeles International. Now we're looking, this is north. North is up. You see LAX over here. Now, I want to point something out to you. You see this, LAX is shown with almost exactly like it looks, with the 2 sets of parallel runways. Ontario is shown the same way. Over here, it's March Air Force Base. It's the same way. Up here, it used to be an Air Force Base, but now it's San Bernardino Logistics Airport or something like that. The reason they don't just have a circle like they do here, for example, with the little runways in the middle of it, is if the runway is greater than 8,096 feet, then they put an elaboration of the runway rather than the circle. But don't, that's not ever going to be on the test. I just want you to be aware that there is a difference between, for example, this airport, which is Hawthorne, showing one little runway, versus LAX, which instead of being a circle like this is now sort of like a layout of the runways. Okay? So down farther down here is John Wayne Airport in Orange County. Out here is Ontario. And then all these other airports. Now I've landed at every single one of them probably, I don't know, dozens of times, including this one down here, which is Catalina. Remember we talked about Catalina? The airport of Catalina? Well, here it is right here, down in the lower left-hand corner of your presentation there. 1,602 feet above sea level. One of the things I'm also going to teach you is to be able to read the maps and read the numbers and what they mean. And here's San Francisco Bay Area. Now this is around here. See this? This is a solid blue line. This is one of the most convoluted, difficult things to see is the actual Class Bravo airspace around San Francisco. But if you look closely, you can see a blue line here, and there's a blue line here. There's another blue line way up here, and those blue lines all connect. Pardon? Well, no, those blue lines identify different sectors where, for example, if you look closely at this sector right here, see that 10,000 over 30? It means that Class Bravo airspace does not exist from the ground to 3,000 feet. It exists from 3,000 to 10,000, and it doesn't exist above 10,000. So that 10,000 over 30 represents the area that Class Bravo airspace exists. And it's with the exception of the center right here. You see this right here? 10,000 over SFC. All right? That means that that's the core, right over the airport, where Class Bravo goes right down to the surface. SFC, surface. Okay? And it turns out that Class Bravo airspace obviously is San Francisco International, but here's Oakland, and Oakland has a solid magenta line. So what class is that? Huh? Class, what is it? Class Charlie. Class C, Class Charlie. All right. And then out here, you have what? Around Livermore. What kind of a dash line is that? It's a blue dash line, right? Doesn't it look blue? Looks blue to me. Okay, so we'll continue on. I want to point out some other things here. So we Class C, we just talked about that. That's FAT. Class C, commercial. So you remember Class C, commercial. It's not as important as Class B. More important than Class D. You could say that Class C is right in the center of the three most important airport classes, B, C, and D. So C is in the center, C is commercial, B is big jets, D is density. Standard cloud clearances, 1,000 below, 500 below, 1,000 above, 2,000 horizontal. Are there any changes to that above 10,000 feet? There are no changes because Class C and Class B don't go above 10,000 feet. They are bounded airspaces. So most Class Bravo airspaces go up to 10,000 feet, and you're probably never going to be asked this question. But just remember, keep it in mind what I'm telling you right now. Class Bravo airspace usually ends at 10,000 feet. Class Charlie airspace usually ends at 4,000 feet. Class Delta airspace usually ends at 2,500 feet. So they don't go all the way up. So you can overfly these airports as long as you stay out of their bounded airspace. So that's why it's so important to remember bounded airspace, because it's bounded not only in a circle, but it's bounded on top as well. None of these airports go up all the way up to Class A. None of them. So Fresno Yosemite, surrounded by magenta, solid magenta line. Because the runways are nearly 10,000 feet, they're shown, the two runways, the parallel runways, they have 2.9 right and left and 1.1 right and left is the reverse. Over here is Fresno Chandler. Here's Reedley Airport here. Selma's down here, right here. Here's Quinn, which is that Caterpillar dealer, has a big, long 5,000-foot runway between 99 and the Golden State Freeway, the Golden State Highway, I guess it's called now. Up here is Sierra Sky Park. Over here is Madera. Okay, so Class Charlie airspace, Fresno Air Terminal. And it only goes up to, what's the maximum that it goes up to? Somebody guess? What? But look at it. What does it say? Yeah, 4,400. Why is that? Because, and I didn't tell you this, because they take the height of the ground at that point and they add 4,000 to it and then round it off. So Fresno Air Terminal is 333 feet above sea level. Right? So you're standing on the ground. You are 333 feet above sea level. Then they add 4,000. So that makes it 4,333. And they round it out to the nearest 100. That's why it comes up with 4,400 as the top. So if I fly at 4,500, I can go right over the top of Fresno Air Terminal. Or out here in this little part of the ring, if I stay under 1,600 feet, I can fly right up to the edge right here, which over here, see this big circle here, it's 44 down to the surface. So this whole area in here goes all the way down to the surface. I can't fly there without permission. Tucson International, this is a little easier to see because it's not as cluttered as some of the other places. But again, you'll see that 6,600 feet. Why is that 6,600 feet? Didn't I just say that 4,000 feet is what they have for the height of a Class Charlie airspace? Okay, what is the sea level? 4,200? No, I don't think you meant that. What is the level? What is the elevation of this airport? Subtract 4,400 from it. Subtract 4,000. Remember I said it was 4,000 added on? So subtract 4,000. 2,600 feet, right? Here it is here. 2,643 is the sea level, is the height above sea level. 2,643 and they add 4,000 to that. That makes it 6643. And in this case, because it was lower than 50, they rounded it down. Okay. I don't want to tax your brains at this point in time. Class D, 3 miles visibility, standard cloud clearances. Here's Lemoore Naval Air Station. Everybody see Lemoore down here? With a blue dashed line around it. Class D, Delta. Class Delta is Lemoore Naval Air Station. And then, as long as I've got you looking at the chart, over here is Visalia, which has a dashed magenta. So what class airport is that? E, correct. Here's Fresno up here. Here's Lemoore down here. Here's Visalia over here. Here's Corcoran. So, you just need to get used to looking at it. Now, while you're looking at it, here's an MOA, isn't it? This boundary right here, Lemoore A, which designates it as a particular kind of military operation area. Here's Lemoore B down here. Pardon? It's Alpha and Bravo. Sure, you can call it Alpha and Bravo. They just showed A and B here. But the different sectors of the fighters that the Navy has coming off of Lemoore Naval Air Station, here's Lemoore Charlie MOA, and it's bounded by these hash marks. Now, I mentioned faded in or faded out. All right, see this magenta? It's faded in. So the denser part of the line is out here. The fade goes in. So it fades lighter and lighter as it goes in. I'll talk about that later. I don't want you to get confused right now, but you can see a lot of things around here have faded magenta. One of the reasons I'm going to tell you right now, and I'm going to repeat it a number of times, up here is Firebaugh, right? Firebaugh is right near Mendota. Mendota has nothing around it, but Firebaugh does. It's because Firebaugh has an instrument approach, and therefore, Class Golf airspace only goes up to 700 feet, not 1,200. We'll talk about that later. There's a difference. So anything that has that faded magenta around it changes the height of G from 12 down to 700. Class E, everything else, like Visalia, dashed magenta. Same thing, visibility 3, standard cloud clearances. There's Visalia. Oh, we're down to the lower right. So we just looked at that. We also looked at Lemoore. Now we're looking at Visalia again. Class E airspace. Okay, here we are with Warm P again, right? There's Lawrence Livermore National Laboratories. That's a restricted area over here. Tomorrow I'm going to hand out full color for each one of you, full color 4 areas that show every single kind of airspace that we've been talking about. And they're yours to take home, but make sure you put it in your binders or put it somewhere where you can access it, because that kind of thing you're going to get from me is the kind of thing you're going to see when you take your exam. Okay, so Lawrence Livermore over here, restriction, that little area right there with the blue hashed marks. Camp Pendleton, we talked about that before. Here it is here. This is San Diego down the bottom. This is Orange County Airport right up here. And between them is Camp Pendleton, and here is the boundary for the restricted airspace. It's restricted 2503 Bravo and Charlie. And out here is 2503 Alpha. Okay, so, and again, we'll go right along with the standard visible clearance requirements. Okay, changes take place only for unbounded airspace. Above 10,000, cloud clearance and visibility increase. This is sort of a summary of the changes in visibility and cloud clearance requirements. There are no changes for Class A, B, C, and D. Bounded Class A, B, C, and D. The changes are only for unbounded airspace. We looked at this before. We'll cover it again when we get to aeronautical charts. Aeronautical maps back cover. Remember, one of the questions was, where do you get information about the charts and the symbols on the charts? The answer is the back cover of the aeronautical chart. Jacob.
So when they launched that SpaceX rocket, was it restricted airspace around it?
Oh yes, it was called a TFR, temporary flight restriction. Temporary flight restrictions are put in place for space launches, for fires, for high government officials who are going to be landing at a particular airport, like either the president, the vice president, or even some of the cabinet members, like the Secretary of State. Temporary flight restrictions, and they are very specific. They give a boundary, a lateral boundary, and an altitude, and they are very specific about the time of that temporary flight restriction. When does it begin and when does it end? So I would encourage you, if you haven't done it up till now, to go home and look at that test just to see how many you think you can get that you can answer. It goes quickly. It should take you no more than 20 minutes to go through that entire test and provide answers.